All right, this is the lesson over arithmetic of radicals. We already did adding and subtracting on the last lesson, so we're just doing multiplying and dividing today. So when we multiply radicals, you just multiply any numbers on the outside together, any numbers on the inside get multiplied together, and then you simplify if you can. So on this one, multiply the outside numbers together, 5 and 2, multiply together, get 10. Then the inside numbers together, 5 and 2 get 10. And you simplify this if you can. All that means is that if you can break this apart into pairs, you do it. We get 5 and 2, but that's it, and there are no pairs, so you actually can't simplify that. You do not simplify by dividing. This is not a division symbol, it's a square root. So you can't simplify this to 1 and 1 or anything like that. That's just your answer. So if there's no number on the outside, really it's an imaginary 1, but if you multiply 1 and 1, you just get 1, so you don't have to even worry about that. So this would just be radical 10. So 6 times 6 gets you 36 under a radical, but the square root of 36 is just 6. Now that one's important because we do a lot of that, especially when we divide, where you multiply by the same thing under the radical. It's kind of like doing the square root of 6 squared. Well, these are opposites, so they kind of cancel each other out. So that's why you just get the number under there. So on the next slide, when you do radical 10 times radical 10, it's just 10. Now if you want to do this step in the middle where you get 100, but under the radical you can, but once you take the square root, the radical goes away and it's just 10. Now this would really be radical 64, but the square root of 64 is just 8. So you can get in the habit of skipping this step and it'll save you a lot of time. So here we have 5 times negative 2, that's negative 10. And radical 4 times radical 4 is just 4. It's a lot like these. But because this one confuses some people, I'm going to go ahead and write that as radical 16 just so you can see it. Now this is 10 times the square root of 16. So 10 times the square root of 16, when the square root of 16 is 4, is like 10 times 4. All we did was take the square root of 16 to get 4. So that is negative 40. Now you could have skipped this step, but it confuses a lot of people when I multiply radical 4 and radical 4 and get 4, but I put it in parentheses. But that's just because I want you to know you're multiplying. You don't just write them next to each other. We didn't do that here because these just had a 1. So it was really just like 1 times 8 and 1 times 10, which didn't really matter. Okay, so here you multiply the outside numbers together. 3 times 3 is 9. Then you multiply the inside numbers. 15 times 5 is 75. Now you simplify it if you can, so let's try to see if we can get any pairs. We know 15 and 5, because we just multiplied them together, we'll get 75. And then that's 5 and 3. So if we were just doing 75, it would be 5 radical 3, which is the answer I get a lot on this. But don't forget this 9 out here. So we bring out a 5, and we have a 3 left over, because it cannot pair with anything. So 9 times 5 is 45. And you get 45 radical 3. So the last step on the first slide says simplify if needed, and that's what that means. Like after you multiply them, if you can simplify it, do it. Now when we're dividing is also called rationalizing the denominator, because in geometry, anytime we're dividing, we write it as a fraction. So if I tell you to divide 12 by radical 3, you write it like a fraction. Now, you can't actually divide that the way you're used to dividing because it's not like 4 or anything. This one's inside a radical, this one's not, so you can't put them together. So whenever that happens, you have to identify whatever radical's in the bottom, because when you are dealing with radicals, they're not allowed to be in the bottom part of a fraction. That's why it's called rationalizing the denominator. You take the radical out of the denominator. So to do that, to get this radical out of there, you'll have to multiply by whatever is under there. So in this case, it's a 3. Now remember, this right here, anything over itself is 1. So really, you're just multiplying this by 1, so you're not changing the value of this original fraction. You're just making it look different. And so then we'd simplify it. And I'm not going to do this problem because that's not the one on the notes, but that's just what I mean. So this is radical 5 divided by radical 3. So you can't have this radical on the bottom, so you multiply by whatever's under the radical on the bottom. Just the bottom. The top doesn't matter. You're going to multiply the top. It just doesn't matter if it's a radical or not or what it is. So radical 5 times radical 3 is radical 15. Now radical 3 times radical 3 is the whole number 3. Now you can put radical 9, but the square root of 9 is 3. The whole point of this is that whatever's on bottom, you're multiplying by that so that it's a whole number. So if you don't get a whole number, you're not doing it right. You cannot reduce these because one's inside a radical and one is not. So that is your final answer. Okay, so anytime you have two things outside the radical, you can reduce them if possible. If they're both inside the radical, you can also reduce them. You just can't reduce them if it's one of each. One inside and one outside. So these are both inside the radical. So you simply reduce the fraction 15 over 20. Some of my classes were struggling with this, but all I'm saying is you guys know 2 over 4 is the same as 1/2. So 15 over 20 is the same as what fraction? I know the radicals are there, but your answers will just be in radicals. So if you reduce 15 over 20, it's like dividing each one by 5, you get 3 over 4. Now, if you want, you can multiply top and bottom by radical 4, just like we did on the last slide. But this one's actually easier because you can take the square root of 4. So before you worry with multiplying, go ahead and take the square root and you'll just get 2. And then the radical takes care of itself in the denominator. So that's your final answer. On this one, I would always reduce first, so you can reduce 6 over 12 to 1 over 2, but those are both in radicals. Now the square root of 1 is just 1. You cannot take the square root of 2 and get a whole number, so we have to leave it as radical 2. So to get that radical out of there, you got to multiply top and bottom by radical 2. So 1 times radical 2 is radical 2. Radical 2 times radical 2 is the whole number 2. And that's your final answer. Okay, nothing can simplify on this one. So I'm just going to start by multiplying top and bottom. You do not have to multiply by this 2 out here, just whatever's under the radical on the bottom, which is 3. So radical 2 times radical 3 is radical 6. Then you have the 2, and then radical 3 times radical 3 is just 3. So you end up with radical 6 over 6. Now, if you could reduce that or simplify that, you would, but there are no pairs that come out of 6. Also, if you end up with something like 6 radical 2 over 12, if you can reduce these numbers, you would. Since that's 1/2, you could just write 2 over radical 2 over 2. You could put the 1 there for the 1/2, but you wouldn't have to. Now that's just a problem I made up. It doesn't have anything to do with this problem right here. I just wanted to let you know that.